Okay, so now let's start at number 16 and just go through them one by one. So what is the mass of 2.35 moles of glucose? And glucose is this formula, the C6H12O6. So any of these mole conversion problems, we're just doing dimensional analysis. We're going to start by writing our value, our unit, and our substance down. And our value here's the 2.35. Our unit is moles, and then our substance is this glucose, but we're going to put in the formula. So I'm going to underline the formula as the substance. So let's see, 2.35 moles, MOL, of glucose, which is C6H12O6. Now I'll put it over 1, put times the conversion factor. And we know we want this moles of C6H12O6 to cancel out. So we're going to drag and drop that on the bottom. Moles C6H12O6. And then we want to convert to some new unit. And it says, what is the mass? And well, mass isn't a unit. That's a quantity that we're measuring, but we know the units that we do measure mass in. But if we want to know the mass of something, we put it on a balance, we measure it out in grams. So when it says what is the mass, it's asking for what is the number of grams. So the grams is going to be our target unit there. So when we're making our conversion, we're getting rid of moles and we're going to go into grams. Grams of C6H12O6. Okay. So just like we did before, whenever we see mole, we're going to put a 1 next to mole, and then we know 1 mole is going to equal some number of grams. And the number of grams that's equal to a mole, that's what molar mass is the mass of 1 mole of any pure substance. So in this case, we're talking about 1 mole of C6H12O6. So we need to know the molar mass of this C6H12O6. 1 mole equals some number of grams for C6H12O6. And normally we would have to add all this up, but we actually already did this in a previous problem. So I'm going to cheat a little bit. We're going to go back and look at what we got before. Let's see. It was back somewhere. We just did it. Let's see. Moving right down. Here it is. What is the molar mass of C6H12O6? Well, we added up 6 carbons and 12 hydrogens and 6 oxygens. When we added that all together, we got 180 grams per 1 mole of C6H12O6. So if we come back over, let's see, I'm going the wrong way in my packet here. We come back over here, 1 mole of C6H12O6 is going to equal 180 grams. So we'll put 1 mole equals 180 grams. And then when we put this in our dimensional analysis, we just pair up the units. We put 1 next to mole already, and so we're going to put 180 next to our grams. 180 grams. Questions on that so far? Okay. Well, then all we have to do is type this into a calculator. So let's see. We're getting out our calculator here. Get some light on my calculator so you can actually see what I'm typing in. Maybe. Ooh, maybe that'll work. Maybe not. It's working a little bit. Okay, so let's see. 2.35 times 180. So let's do 2.35 times 180. And then divided by 1, but we don't need to type that part into our calculator. So 423. Equals 423. And we need to look back at our significant figures in our problem. So right here we have 2.35 that has 3 significant figures. So our answer also should have 3, and it already has 3, so we're good on that front. So then we just need to look for our units. The moles cancels out, and we're just going to be left with grams of C6H12O6. There we go. There's our final answer. Okay, so number 17, how many moles are in 98.3 grams of potassium chloride? So we're starting off the same way. We're going to write our value, our unit, and our substance. But I don't want to have to write potassium chloride, those words out every time, so I'm going to figure out its formula. So to do that, I'm going to crisscross. Potassium is K, and I'll look up its charge. Let's see. It's over here in column 1, so it's going to have a +1 charge. And then chloride, that would be Cl, and chlorine's over in group 17, right here, so it has a -1 charge. So then when we crisscross, the formula is just K1Cl1, so KCl. So that'll shorten what I have to write down, and it'll also help when I need to find my molar mass, because I'll know what my formula is. Okay, so now let's write it down. 98.3 grams of potassium chloride. I'll put it over 1. Okay, and then I'm going to multiply by my conversion factor. I want that grams of KCl to cancel out, so I'm going to drag and drop that on bottom, grams of KCl. And then I'm trying to get to a new unit, so I'm going to look next to my question word. It says how many moles. So I'm trying to get to moles. That goes on top, moles of KCl. Okay, so now I know I have to fill in some numbers. Anytime I see mole, I know I put a 1. So 1 mole of KCl is going to equal some number of grams. And to figure out that number of grams, I need to calculate the molar mass of KCl. So let's do that over here. Molar mass of KCl. So I have 1 potassium and 1 chlorine. So this should be a pretty easy one to add up. So let's look up those masses. Potassium is 39.098. And then chlorine is 35.453. I need to add those up. Let's see. 39.098 plus 35.453. So I got 74.551 grams equals 1 mole for KCl. Okay, so then I'm going to take this number of grams and I'll put that next to my grams on the bottom. 74.551. All right, so I have my whole problem set up. Any questions so far?
No.
Okay. So now we just need to put the rest of this into our calculator. So this time I have 98.3 times 1 divided by 74.551. So I know that 98.3 times 1 is still going to be 98.3. So I'll skip putting that in my calculator and I'll just put 98.3 divided by 74.551. And for me, I can select that in my calculator and just click that down. So 98.3 divided by 74.551, that gave me 1.3185. Okay, and now looking back at our sig figs, we have 1, 2, 3 significant figures up here. So our answer also needs to have 3. 1, 2, 3. And we'll look at that next digit over. So we're going to have 1 point. Whoops, I almost forgot that decimal point. 1.3, and then the 8's going to make that 1 round up to a 2. 1.32, and then grams of KCl will cancel out, and we'll just be left with moles of KCl. There's my final answer. Okay, so 18, what is the mass of 0.985 moles of titanium-2 sulfide? So we have our value, our unit, moles, and then our substance, this titanium-2 sulfide, but we need to figure out what that formula is, so that means we're gonna have to crisscross. So titanium is Ti, and remember that Roman numeral in parentheses tells us the charge of our metal. So it's telling us the charge of that titanium. So because it's Roman numeral 2, that means titanium has a +2 charge. Because we wouldn't know that looking at our periodic table, because titanium's in this transition metal section, so we don't know its charge just looking at the periodic table. It has to be told to us. And then sulfide, that would be sulfur. And looking back at our periodic table, sulfur's over here, and it has a -2 charge. So sulfur is going to be -2. So then if we crisscross, we're going to get Ti2S2, but we know that'll reduce down to just TiS. We simplify that down to just TiS. Titanium 2 sulfide. Questions so far? No? Okay, yep. Cool. So now let's write it out. 0.985 moles, MOL, of titanium 2 sulfide, TiS. And then we'll put that over 1 times conversion factor, and we'll put our equal sign. Now, we know we want that moles to cancel out, so we'll drag and drop that on bottom. And then on top, we're trying to convert to our new unit, what is the mass? And remember, we said that mass is the quantity, and the unit that we measure mass in is going to be grams. So we're trying to convert to grams. What is the number of grams? Grams of TiS. So we have our whole setup. We have to fill in some numbers. Anytime we see mole, we put a 1. So 1 mole of TiS equals some number of grams. And we have to figure out how many grams that is. So titanium plus sulfur, we need to add up those masses. So we have titanium, sulfur, and since there's only one of each, I'm just going to write the masses underneath. So titanium is 47.867 plus sulfur, whose mass is 32.065. I hope you have your own periodic table because it's kind of hard to see mine. 32.065. We'll add those up to get our molar mass. I'll label this molar mass of TiS. So let's see. Do this in our calculator because I can't do that kind of math in my head. 47.867 plus 32.065. So I got 79.932. So I'll take this and I'll put it in for my number of grams. There's 79.932 grams in every 1 mole of TiS. Okay, so we did all that work to set it up. Now all we have to do is type this into our calculator. We're going to type in 0.985 times 79.932 divided by 1. But we know if we divide by 1, it's still going to be the same thing, so we don't really need to do that part in our calculator. Let's see. 0.985 times 79.932. We got 78.733. And then we need to round to sig figs. Looking back, we had this first 0 is not significant because it's a leading 0, but the other 3 digits are. So we have 3 significant figures, so we need to round to 3 in our answer. And then we'll look at 3 to tell if we round up or down. 78 point, and that 7 is going to stay a 7 because 3 is not more than 5. Let's see, moles cancels. So our units will be grams of TiS. There's our answer. Perfect.